So this is chapter 2 on measurement. What you're going to find is that you have done basically everything in this chapter, but you're expected to be able to do everything. So you're expected to be able to graph, you're expected to be able to interpret data, you're expected to be able to measure correctly. This was the focus of your summer packet, and this is what you should be able to do. So the first part of this is about scientific method, which again you've heard about lots of times, so we'll just kind of briefly go over it. A couple of things you want to remember is we're going to look at it from the chem perspective, so kind of how do we use it specifically. And one thing is we're just using it to problem solve, so it's just ways that we can use to try and solve problems. So you want to keep in mind that anytime you're doing science, the first thing you're going to have to do is use your senses. So when you're doing labs, you need to make sure that you're really taking careful observations. If you don't take the time to really pay attention, then it's not really the point of it. When we do a lab, it's so that you can see interactions and you can see trends, and that's what we're hoping for. When you're doing chem, you want to try and make sure that you're trying, at least in the lab portion, to stick to observation. And again, that's going to be something that's very apparent, something that's true, something that if we all looked at it, we would all say the same thing, like, oh yeah, that's blue. Oh yeah, it has a mass of blah, blah, blah. So things that are irrefutable. One thing you want to be careful with is the inferences. And again, later, once you've analyzed your data, you may use inferences. But there's something you have to be careful of because there's something that you're assuming to be true. And one thing that you're doing with this is you're basing it on prior knowledge. So what you're doing is you're trying to make sense of your world, and you use your observations you've taken, and you try and explain it, because we all want to explain things. And what you have to be careful of is that if you have different prior knowledge than someone, then you can make different assumptions. And that's not good in science, because we want to be as stringent and as logical as possible. So just keep that in mind while you're doing your lovely science. Second thing you do generally in the scientific method is you generalize. So before you do anything, you have to look for a pattern. You have to look for something that you're interested in. Again, a lot of times in school, they tell you what they do and they tell you what you're going to research. But when you're a scientist and you're doing chemical research, you have a million different options that you can go in. Now, if you're working in business, you may have a direction that your boss tells you to, but you're going to come up with your own plan on how you're going to do it. And again, this is a lot of research. This is not just like, oh, here's a lab paper, go do it. A lot of people don't realize it, but if you're going to be a research scientist, it's very creative. You have a lot of control over your day-to-day operations. So this is a lot of that. Then you're going to formulate a hypothesis. We all know, educate a guess. It has to be testable. So a couple of things about that you've heard since kindergarten, but it has to be educated. So you have to do your research. And like we said, in school, we typically, not always, but we typically do give you that kind of background. We give you the supporting information. But I cannot just say that I think the moon is made of gummy bears, because that would be really cool for me, because then I could pretend to go to the moon and get gummy bears. So you have to actually have reasons for it. And before you get funding from anyone, you're going to have to validate that, and you're writing large chunks of grants about why you think what you think. It also has to be testable. So a lot of things, if you're using animals or anything like that, or even like a new drug, you have to be ethical. You can't be like, hey, let's see if we dose kids, what happens to them? There's a lot of ethics behind science, and you have to, follow that. So again, big thing, ethics, and that you're very logical. A lot of logic comes into chem. So then the part that everyone likes is the actual experimentation, and obviously this is when you make your observations. When you do your experiment, you're going to reject or support your hypothesis. If your hypothesis is rejected, you go back and either reevaluate, do what you need to do. If your hypothesis is supported, you do further testing, and eventually you can start having generalizations. And generalizations lead to theories and eventually laws. So one thing you want to make sure you know the difference between is a theory and a law, because they are different. So a theory explains behavior. So if you think of theory of evolution, theory of relativity, these are things that have whole books written about them. Albert Einstein wrote a huge paper on it and won a Nobel Prize for it. So this is things where you don't just come out and say, hey, I know why HIV is the way HIV is. You explain yourself and you have a theory behind it. And a lot of times when you have theories, you have models. So models are, think of plate tectonics, DNA models, I think Mr. Phillips even may have had you make like a globular protein model, stuff like that. But a lot of times when you have a theory, you have models that go along with it to kind of help people interpret what you're trying to say. And eventually, if your theory kind of holds up for a long, long time, then you can have an actual law. And a law is a description of a behavior. But an important difference here is there's no explanation. So if you think of like Newton's 3 laws, Newton says that for every action there is an equal and opposite reaction. He does not like explain himself. He does not give you a little like a packet of information. Didn't make a little tutorial for you or put a video on YouTube. So it's basically come to the conclusion that that is fact, and you don't really have to explain it at that point. So there are differences. A couple other things here just to keep in mind, which will be the end of this section, that are just some things to keep in mind when you do experiments. Because in this class, you will be responsible for coming up with your own experiments. I mean, I'll certainly give you guided information, but you will be in control of things. So when you're doing an experiment, please make sure that you are taking both qualitative and quantitative data. Chemistry is very heavy on the quantitative because we typically care about numbers. We typically do a lot of math and we like to crunch them and see what does that tell us. But it's just as important if something turns blue, or it's just as important if it gave off a smell. So you need to make sure that whenever you're doing any labs, that you are just as much about qualitative and quantitative, and that they're high quality. If you're not even taking the time to write something neatly, then why should we bother to read it? So just make sure that you're showing us why it's important to you, so that it's also important to other people. When we do experiments, we have our variables. Remember that you always want to have an independent variable. That's what you are controlling. And you always want to have your dependent variable, which is what you're looking at. So if all of a sudden I'm going to make you guys eat different diets and see which diet's the best or whatever, my independent variable will be the food I'm feeding you in this particular diet I'm giving you. And my dependent variable could be like, how much weight you gain or stuff like that. Like if I'm going to make you eat all candy bars all day or something. So if you don't have an independent and a dependent variable, then you don't really have an experiment. And if you are in AP Stat, you'll talk about lurking variables. You have to be very aware of what you're doing and try and control the environment as much as possible so that you don't have lurking variables that could affect your data that you don't really realize. Sometimes this is hard if you're dealing with thousands of people and you're doing like a medical research thing, but you have to make sure that you try as much as you can so that you can see that there is a logical connection between the two. And then we also have our controls that we use to have that comparison. So if I do nothing, what happens?